Problem 4. The Medicine Corporation of Monopolies receives a report from a consulting firm concluding that the demand function for its product is linear and is equal to Q equals 78 minus 1.1p plus 2.3y plus 0.98, where Q is the number of units sold, P is the price of a unit in dollars, Y is per capita income in thousands of dollars, and A is the firm's advertising expenditure in thousands of dollars. The firm's average variable cost function is ABC, measured in dollars, equal 42 minus AQ plus 1.5 Q squared. Question A and B, can you determine the firm's marginal cost curve and marginal revenue curve? Question C, if the per capita income Y is 4,000, but then when you plug in back there, you should include as 4, because the equation already taken care of the unit as 1,000, right? Same thing for advertising expenditure, 200,000. You plug 200 into the equation. So given this information, can you determine the price and output where marginal revenue equals marginal cost, aka profit maximizing quantity and price? If so, what are they? Alright, question A, can we determine the firm's marginal cost curve? The answer should be, hopefully, yes, right? So question A, you need to derive marginal cost curve or equation, which is the change in total cost divided by change in total quantity of output. But then remember, total cost is the sum of total fixed cost and total variable cost, right? Total fixed cost and total variable cost. Then there's no change in total fixed cost because it's fixed at constant. So there's no change here. So change in total cost is equivalent to change in total variable cost divided by delta Q to derive marginal cost. So here we don't have total variable cost. We have average variable cost, which is total variable cost per unit, right? So by multiplying Q, you can derive total variable cost. So we know total variable cost is 42 minus 8Q plus 1.5 Q squared, that is given in the equation or question. So multiply Q to each term, this becomes 3, right? You can derive total variable cost, and when you apply delta operation to total variable cost or basic calculus, and you do it according to the change in total quantity of output, you have 42, 8 multiply, you have 2Q here, 1.5, Q3 become 3Q squared, right? So this is 42, 16Q, and 4.8 Q squared, that is marginal cost curve. Alright, so there was a typo. Here is 4.5 instead of 4.8. Well, unfortunately, nobody stopped me before because it's online class, right? So remember, this is not 4.8, it's 4.5. So question B, marginal revenue. The answer is yes, you can derive or determine the firm's marginal revenue curve. So as we have linear demand function, 78 minus 1.1p plus 2.3y plus 0.9a, just rewrite this to inverse demand functional form. So p equals 78 plus 2.3y plus 0.9a minus q and divide by 1.1, and that is inverse demand function, right? So marginal revenue curve has the same vertical intercept, right, to the demand function. So 78, 2.3y plus 0.9a divided by 1.1, but then it's twice as steep as the demand function, so you multiply 2 to the slope of the demand function, inverse demand function. So this marginal revenue curve, right? Now let's move on to question C. So question C, per capita income Y measured in $1,000 is given as 4,000. So Y, you plug in 4, and advertising expenditure also measured in thousands of dollars. You have 200 plug in instead of 200,000, right? So plug these numbers to marginal revenue curve. Then for profit maximizing which is marginal revenue equal marginal cost, profit maximizing price and output can be found by equating marginal revenue and marginal cost, right? So you're equating 42 minus 16q plus 4.5q squared equals to, so when you plug these numbers here, if you do calculating, then you can find 242.9 minus 1.82q, right? So solving this quadratic equation, so if I rearrange it, I have 4.5q squared minus 14.18q minus 200.9 equals 0. So you can calculate it by using some formula that you can easily find from your textbook or from the internet, or you can use scientific calculator. Then you can find Q equal for 8.44, and the optimal price, profit maximizing price, is $235.24. Thanks for watching.